Bismillahirrahmanirrahim, guys. Once again, Mr. Atik is here from the science department. We have the physics lecture, week 15, the second physics lecture for Tuesday. We discussed chapter 14, section 1, and the question 9 and 10 we didn't solve at that time for the Sunday lecture. So in this lecture we will try to cover the remaining question. Now look at this was the question for section 1. Okay, find the angle 9. Look at it, says what? Find the angle of refraction of ray light incident fused quartz in R 1.458 from the water Ni 1.33 at an angle 35. Answer is a descriptive one. As wave fronts enters a transparent medium, they slow down, but the wave fronts that have not yet reached to the surface of the medium continue to move at the same speed. So during this time, the slower waves fronts travel a smaller distance than do the original wave fronts. So the entire plane wave changes its direction. Got the idea? Okay. Question 10. A. How does the speed of light in air is 3.0 raised 10 to the power 8 meter per second. A. How does the index of refraction relate to the speed of light in a medium? Look at the answer says the refractive index of refraction. So the refractive index of a medium N is equal to the speed of light C divided by the velocity of light through the medium V. Rearranging the equations allows us to see the relationship regarding V. The lower the refractive index, of course, the faster will be the velocity of light. The lower is the refractive index, the faster velocity of light will be. Okay, for the B option, the index of refraction of water is 1.33. What is the speed of light in water? It is denoted as N is equal to C divided by V. Rearrange them. V is equal to C divided by N is equal to 3 cross raised 10 to the power 8 meter per second, like velocity of light. 1.33 divide, look at it, we are going to put the value, this is the C value, 3 cross 10 raised to the power 8 meter per second divided by N is 3, so this is what N is given to us by 1.33. okay, refractive index is what? 1.33. so it is equal to 2.25 raised 10 to the power 8 meter per second. Therefore refractive index of all of the water can be measured by the speed of light in water is 2.25 raised 10 to the power 8 meter per second. Understand? So the speed of light in water is 2.25 raised 10 to the power 8 meter per second. Got the idea? Now we have for this lecture chapter 14. That was the remaining things, what we solved for the question 9 and 10. Now chapter 14 section 2, we will solve few options in it, and then in the upcoming Thursday lecture we will continue it then. Okay, write the letter of the correct answer in the space provided. All of the following statements about real and virtual images are true except one. What? Real images can be projected onto a screen, virtual images cannot. Number 1 option. Both converging and diverging lenses form real images. This one is the correct one, by the way. The C option is a real image is formed when light rays intersect. D. Virtual images form at a point from which light rays appears to come but do not actually come. Second is a slightly ray passing through the center of a thin lens and both of its focal length is number A refracted, number C possible, not possible, B not refracted, D called the focal ray, B not refracted. The size and location of an image formed by the converging lens depends on what? Location of the object in relation to the lens, B location of the image in relation to the lens, C location of the observer in relation to the lens, D all of the above. The fourth one, this is the A option, okay, correct one. For the fourth options of chapter 14 section 2, the image formed by a diverging lens is what? A always virtual, diverging lens, remember, always smaller and always upright. Yes, all of the above. Diverging lens can give us three phenomena: virtual, smaller and upright. So this was today's lecture for the Tuesday. In the upcoming, for the Thursday lecture, I will upload another video.